Okay, here is a typical question you would get for transformation. They will ask in the example. They will ask you to describe the transformation from transformation from equation 1 to equation 2. Okay, the idea to describe it, well, we follow the basic rule. Okay, reflection first, then dilation, then translation. Okay, since because we are not describe the transformation of a graph from a standard equation, then it's going to be a little bit different. Okay, so for instance, let's describe the reflection first. Okay, because I say a minus there and a minus in the second equation, okay, and I don't see any minus signs in the first equation, so there will be a reflection on x-axis and a reflection on y-axis. Okay, so the thing is reflection on x-axis and reflection on y-axis. Okay, that's the only two I can find. So now let's move up to dilation. Okay, so first I can say here 10 is in the first graph, the amplitude of the well, in the first graph, there's a 5 times sine something, and in the second graph is minus 10. Okay, the value 10 is double than 5, so there will be a dilation by a scale factor of 2 along y-axis. Okay, to find, because it's in this case we have 5 and 10, which is very simple, so there won't be a okay, there won't be any trouble to find it. If you have trouble, okay, what you can do, if you have trouble to find the scale factor, what you can do is, okay, we know there's a dilation, okay, because the value here is different than the value in the second graph, so there's a dilation along y-axis, okay, by a scale factor of, okay, 10 divided by 5, which is 2. Okay, that's the mathematical way to find it, just 10 divided by 5. Sometimes you may get a fraction there. Now let's describe the horizontal dilation, and I don't say any because here 2 is same as the coefficient of x in the first, the absolute value of the coefficient of x in the bracket is 2. In the first equation, the second equation is minus 2. Basically, there's only a reflection on y-axis, no further dilations. Now let's move to the translation part. Okay. In the first graph, there is plus 5. In the second graph is 2. So what I can say, translated 2 minus 5, okay, which is minus 3. Okay. Use the number of the second equation minus the number in first equation, I will have 2 minus 5 is minus 3, so it's translated 3 units down. Okay. When it moved up, it's positive. Also, when it moved right, it's positive. Okay. Okay. Now let's make whatever in the first whatever in the bracket of the first equation equal to 0. Okay. 2x plus pi equal to 0, and I will have x equals to minus pi on 2. Okay. And again, okay, let's make whatever in the second whatever in the bracket of the second equation equal to 0. Minus 2x plus 3 pi equal to 0, and x will be, well, positive 3 pi on 2. Okay. Okay. Now let's use the second value 3 pi on 2 minus the first value, okay, minus pi on 2. Okay, which is 2 pi. Okay. Now we have our translated value, horizontal translation value, which is 2 pi units right. Moved 2 pi units to the right. Okay, that's how do we describe the transformation of an equation if the equation is not transformed from the standard graph. Okay.